Okay, you're right. Welcome to your tutorial on algebraic fractions, adding and subtracting. Today we are going to have a look at what algebraic fractions are, and we're going to look at our first two operations, adding and subtracting. Okay, so what is it? Algebraic fractions are fractions that contain pronumerals and represent particular numbers or changing values. Okay, we've kind of learnt that this is what algebra is. It involves pronumerals, which are letters, that involve something that changes. Okay. The methods for dealing with algebraic fractions follow the same principles that we've used for numerical fractions. So when we've learnt how to add 2/3 and 1/6, or when we've learnt to divide 2/3 by a quarter, we follow the same principles when we have pronumerals in them as well. Today we're going to look at addition and subtraction. So that is for addition and subtraction, before we can do anything, we need to find a common denominator. So let's have a look at a few examples. This is my first example, okay? And this will be a little refresher from the start of the year and year 7 last year, okay? It says x on 2 plus x on 5. Now we have to find a common multiple of both 2 and 5 that I can change that denominator to. So 2 and 5, okay? My multiples of 2 are 2, 4, 6, 8, 10. I'll list the first 5 and then I'll do the same for 10. 5, 10, 15, 20, 25. This time I'm listing multiples. Last lesson we were listing factors. This time I'm listing multiples. And I know that 2 multiplied by 1, 2, 3, 4, 5 is 10. 2 multiplied by 5 is 10. And then I know that 10 multiplied by 1, 2. 5 multiplied by 2 is 10. So I have a common multiple across those two, and that's 10. What do I have to do that's going to be my common denominator, okay, is 10. Now, if I'm changing my common denominator to 10, I've multiplied by 2 by 5 to get to 10. If I multiply the bottom by 5, I have to multiply the top by 5. Okay, so 5 times x becomes 5x. All I'm doing here, x on 2, is the same as saying 5x on 10. I'm not changing the value. I'm just finding an equivalent fraction, okay? Now, what do I have to do to get from 5 to 10? I multiply it by 2, okay? What I do to the bottom, I have to do the same thing to the top. So 2 times x becomes 2x. Now I have a common denominator. So my count of my number of parts is the same. So it says 5x on 10 plus 2x on 10. That's super simple. That becomes 7x on 10. Okay, and it's pretty straightforward, guys. It's not too tricky. Let's have a look at another example. Okay, this time I'm looking at a y on 3, subtract 2y on 7. Now I need to find the lowest common multiple of 3 and 7, because this time I'm not looking for numbers that they go into. I am looking for numbers that 3 and 7 go into, rather than numbers that go into 3 and 7. So my multiples of 3 are 3, 6, 9, 12, 15. Okay, I'll list the first 5. 7 on 7, 7 2s are 14, 7 3s are 21, 7 4s are 28, 7 5s are 35. Do I have a common one yet? Oh, no, I don't. Okay, let's list a few more for 3. 6 3s are, I can't go down my list anymore, so I'm just going to go over here. 18, 6 4s are 24. Oops, I forgot one. 18, 21, 24. Oh, hold on. Wait. I see that there's a 21 in this list and a 21 in this list. What have I multiplied 7 by to get 21? Oh, I've multiplied by 3. What have I multiplied 3 by? What have I multiplied 3 by? Okay, I've multiplied 3, it's clear, by 7. Okay, 3, 6, 9, 12, 15, 18. Yes, 7. Okay, so my new common denominator is going to be 21. Okay, 21. Now, I'm not going to change the value of these. I'm just going to write an equivalent fraction with a new denominator. So if I've multiplied 3 by 7 to get to 21, what I do to the bottom, I have to do to the top. So it's going to become 7y. Now, with 2y, I've multiplied 7 by how many? 3. Okay, so I multiplied 7 by 3 to get 21. I must multiply 2y by 3. Now, 2y multiplied by 3, I deal with my numbers first. 2 multiplied by 3 is 6, y, adding it on the end. Now it says 7y minus 6y. Technically, when I write this out, I get 1y divided by 21. But is that my right answer? Is that correct? Or can I write 1y on 21 in a more appropriate way? And I'm hoping a lot of you have just said to yourselves, oh, that's the same as saying y on 21. Because when I have a 1 in front of a pronumeral, I don't actually need it there, okay? I don't actually need it. If I write the pronumeral by itself, that represents the 1. Let's have a look at another example. This time it's a little bit more tricky, okay? This time I've got my pronumeral on the bottom, okay? This time I've got my pronumeral on the bottom. Okay, so I need to find a number that is common amongst both of them. So I've got 3y and 5y. 3y and 5y. For the moment, I can actually just kind of ignore the y's. If I ignore the y's for the moment, that's not a bad thing. So my multiples of 3y become 3y, 6y, 3, 6, 9, 12, 15y, I'll write the first 5. Technically, there's a y on all of the end of them. But if you can see, what I've just done is I've just taken the 3 and I've just multiplied the numerator. So 3, 6, 9, 12, 15. So technically, I need to remember there's a y on the end, but it's not all that important at the moment. Now, 5, 10, 15, 20, 25. Oh, wait, hold on. I don't even have to write the 25. I already see that there's a common multiple, okay? And it's 15y here, and there's a 15y here. What have I done from 3y to get to 15y? Well, 3 multiplied by 1, 2, 3, 4, 5, okay? So I've multiplied 3 by 5 to get to 15y. 5y I multiplied by 3 to get to 15y. So my common denominator becomes 15y. 15y, okay? And I multiplied 3 by, how many did I say? Okay, I multiplied 3 by 5. If I multiply the bottom, I have to do the same thing to the top. And 5 I multiplied by 3. If I multiplied 5 by 3 to get 15y, what I do to the bottom, I have to do to the top. Okay, so 3 3s are 9. So then it becomes 9y, oh, I've run out a bit of room. 10y, 10 over 15y plus 9 over 15y becomes very simply 19 over 15y. Remember, I always ask myself when I get to the end, can I simplify this? And the answer is no. So 19 on 15y is my answer for that one. That one's a little bit different because my pronumeral is on the bottom, not on the top. Okay, let's have a look at another example. This time I've got x and 2x, x and 2x. Now, this looks a little bit more tricky, okay, because x, 2x, 3x, 4x, they're my multiples of x, because remember, that's the same as saying 1x. So 1 multiplied by 1 is 1, 1 multiplied by 2 is 2, 1 multiplied by 3 is 3, 1 multiplied by 4 is 4. Okay, and I can keep on going. Now my 2 multiples, 2x, 4x, 6x, 8x, there is actually a common multiple already, and the answer is 2x, okay, because 2x multiplied by 1 is 2x, okay, so my common denominator for these two can actually be 2x, okay, can actually be 2x. I multiply 2x by 1, okay, I haven't really changed that one, but I multiply x by 2 to get 2x. So if I've multiplied I've multiplied the bottom, I have to do the same thing to the top. So it becomes 1 by 2 is 2, subtract 3, okay, 2x, subtract 3x, 2 subtract 3 is actually negative 1. Oh, I've run out of room again. 2 subtract 3 actually becomes negative 1. Negative 1 on 2x, and I actually just write the negative on the outside. I'm teaching you something new. Write the negative on the outside, okay? So I actually just write that as a negative 1 on 2x, okay? And that's it, guys. That is working with algebraic fractions, adding and subtracting.